Okay, guys. Today, March 18th, will be our final kind of major lesson in our unit on stoichiometry, right? And what we're going to talk about is yield and how to calculate a percent yield. So, what we have to understand is when we do chemistry, right, there's what we call the theoretical yield, right? And then, of course, there's our actual yield that we get as a result of an actual experiment, okay? And so what we need to understand is stoichiometry. So when we do all those calculations using the limiting reactant and the balanced reaction to figure out how much of a product you should get, stoichiometry, that gives you the theoretical yield, which is the amount you ought to get, right? So if you were able to conduct that reaction perfectly, right, the theoretical yield would be the amount you would get, right? Now, your actual yield, of course, is what you get when you actually do the lab. Now, you guys have done a lab already where you calculated a percent error, right? So a percent yield is very similar to the percent error. There's actually just kind of fewer numbers involved, and it's probably a better way to look at the yield of a reaction than the percent error is. We really want to know how much you got, not how much you screwed up by, but we'll get to that, okay? So typically, now not always, but typically the actual amount will be less than the calculated amount. That is, of course, unless you're doing like a decomposition reaction, in which case your actual amount might end up being more. But really, it's not so important. You just need to know how to calculate the percent yield. All right? And yes, this is going to involve knowing your limiting reactants and also knowing how to do stoichiometry and knowing how to calculate percent yield. So it's just one more step. We're piling on the multiple steps we've already got, okay? Luckily for you guys, it's a pretty easy step. Percent yield looks like this, right? So we have our actual yield, right? So an actual yield, remember, is that amount you get when you conduct the reaction, right? Over our theoretical yield, which we get from stoichiometry, right? We divide that, and then, of course, to turn a fraction or a decimal into a percent, we multiply it by 100. All right? So that's our formula. It's that simple. Of course, this formula comes in after we've done all the steps to get to our theoretical yield, which would be writing out your balanced reaction, et cetera, et cetera. All right? So in practice, what are we talking about having you guys do? Now, first and foremost, you guys need to be able to read the problem appropriately. All right, so you're going to look for keywords, right? So if I add something, right? So adding or mixing or reacting, right? Those are keywords that tell you that this is a reactant, right? So we're not trying to figure out our percent yield of a reactant. We're trying to figure out our percent yield of a product. Because remember, when we do reactions, in reality, typically there's a desired product that we want to make. All right? And so usually we're going to do our percent yield of one of the products or both, depending on what we're looking for. Okay? So adding, reacting, mixing, right? Those are all keywords to tell you that we're talking about the reactants there, right? Now, look here. I use the word collect, right? So I collect, or I produce, or I make, right? Those are keywords to tell me that that is a product. So silver chloride is a product. So again, collect, produce, make, those types of things tell you that we're talking about the product side, right? So it is, before we even start writing our reaction and figuring out our limiting and excess reactants and figuring out what our theoretical yield is, we need to make sure we understand what is a reactant, what is a product, etc. Okay? So I think it's very, very helpful for a lot of you guys maybe to annotate the question a little bit, at least when we're first starting, when we're practicing these. And then, of course, on a test, you want to be extra careful. Maybe go back and read the question carefully, right? Again, I've taught chemistry actually not that long, but but long enough to know where kids, even my brightest kids, sometimes go wrong. And that's because they're not reading the question carefully enough. All right? Okay, so we know what our reactants are, right? So silver nitrate, and then of course I'm adding that 2 calcium chloride, so that's also a reactant. Okay? And I'm going to produce some products, right? Now we know how to predict our products. All right, so let's go through the next step here. I'm going to actually write my reaction up here in the top. Let's go purple just to make it fun. Okay, so I'm going to add 3.4 grams of silver nitrate. So that's AgNO3, right? Silver's a +1, nitrate's a -1, so 1 of each. I'm going to add that to excess calcium chloride, right? So in this one, I actually tell you which one's excess, so we know we're going to use this number, by the way, for the stoichiometry problem in a little bit. But let's finish writing our reaction first. Calcium chloride, right? So calcium's a +2, -1, so this is going to be CaCl2, right? Now, I know already that one of my products is silver chloride, so that's going to be AgCl, because they're both 1s. And so my other product would then have to be calcium nitrate. Okay, now let me see. I've got 2 nitrates, 1 nitrate, so I'm going to go ahead and put a 2 there and balance that on that side, which also gives me 2 silvers, 2 silvers, 2 chlorines, 2 chlorine. All right, we are balanced. All right, so step 1 done. Step 2, right, is I need to then start doing some stoichiometry. Now, again, I already know what my limiting reactant is, so I don't have to do that step of figuring out what my limiting reactant is. Now, you guys will have to do that with some of these problems, just not this first one. So, I already know, because I know calcium chloride is excess, I don't need to worry about how much of that I have. This is my number that I'm going to worry about. All right? So, here's what we're going to do. We're going to go with 23.4 grams of silver nitrate. All right? And in all stoichiometry problems, we've got to make sure that we're in our magic mole unit, right? So the first thing I'm going to do is convert this gram amount to my mole amount, right? And so I need to add up my molar mass of silver nitrate. So that's 1 silver plus 1 nitrogen plus 3 oxygens. And when I do that, I get a mass of 169.8 grams of silver nitrate. Oops. Sorry about that. Pen got a little goofed up. In 1 mole. AgNO3. I'm not sure what's happening with my pen here. There we go. Now, when I'm in moles, right, so I can do a little quick canceling of my gram unit there. So now I know my moles of silver nitrate, right? My next step then is going to be multiplying by my mole ratio. So again, I'm comparing silver nitrate to the product here, silver chloride. All right? So those are the 2 amounts I'm going to compare. So I have a 2-to-2 ratio up here in my balanced reaction. So again, we're up here at the top, right? There's a 2-to-2 ratio there, right? So I'm going to go ahead and write this out. 2 moles. Man, my pen is just giving me fits, isn't it? Of AgNO3 to 2 moles AgCl. All right? And again, I'm now in moles of silver chloride, right? Now I need to get that to that gram unit, of course. So one more step's going to get me there. 1 mole AgCl will give me 143.2 grams AgCl. Okay? Now, when I do that, what that gives me is 19.8 grams AgCl. Okay. Whew. Okay, so here's what I need to do. So what value does stoichiometry give me? Right? So this here, right, is stoichiometry, right? This whole thing I just did, that is stoichiometry. All right? Stoichiometry gives you what value? The theoretical. Okay, whoops. Okay, so here's what I'm going to do. My actual yield, right? So this is going to be 10.7 grams of AgCl, right? Now, I know that because the yield is the amount of product we get. And down here, when I first annotated this, right? See where I put product here? Silver chloride. The amount I actually collect is that 10.7 grams, right? So this is talking about an actual experiment where I took these amounts, mixed them, a reaction occurred, and I collected 10.7 grams of silver chloride, right? So that is the actual amount I got. So I'm going to set it up as 10.7 grams AgCl over my theoretical yield, 19.8 grams AgCl, and times 100, and I should get 54 point something here, sorry, 10.7 divided by 19.8, 54.0% yield AgCl. Okay? So, that's how we do that. Now let's try another one together that will also show us what we do when we don't already know what our limiting reactant is. And again, we're just building steps on top of steps that we've already done. So one more example problem. All right. So again, I am going to annotate this question. Right. So here's a key word: make. Okay. The word make here, this is our key word. If I'm making something, that tells me it is a product. So this is a product. Okay? And if a product mass is given to me, right? So I made 31.5 grams of calcium carbonate. So that tells me how much I actually got. Whoops. Sorry about that. Yeah, sometimes these touch screens give you a problem. Sorry about that, guys. But anyways, so if I make something, that's my product. And I have this 31.5 grams, which is a measured amount. So this is my actual amount, okay? Now, so I'm reacting. So this tells me that calcium nitrate and sodium carbonate are my reactants. All right? So that's my keyword, reacting. So I'm going to label that reactant and label this reactant. Okay? So now I can go ahead and write my equation up here. So let's go green this time. All right. So anyways, I have a reaction between calcium nitrate. So that's going to be CaNO3 2. And I'm reacting that with sodium carbonate, Na2CO3. Right? And I know that I'm going to produce one of those things is calcium carbonate, and the other, of course, will be sodium nitrate. All right? And again, this is stuff you guys should know how to do, because we've done this lots of times. All right. Now, of course, I got a 2 there, so I just need to put a 2 there to balance things out. All right. So there is my balanced reaction. Now, you'll notice that I give you 2 different amounts of reactants, right? And I don't tell you which is excess or which is limiting, which means, you guessed it, we're going to have to go through all the steps to figure out what is excess, what is limiting. Okay, so let's do that right now. So we have 82.5 grams of calcium nitrate. Oops. The pen's giving me problems. Alright, so 82.5 grams of calcium nitrate. Whoops. Okay, and I need to convert that to moles, right? So figuring out what your limiting reactant is, remember we always have to convert both of our reactants into moles first, right? So we can compare those amounts. So 82.5 grams of calcium nitrate, and that is 164.10 grams calcium nitrate, and 1 mole calcium nitrate. And that is going to give me, 0.503 moles of calcium nitrate. Alright, now I'm going to do the same thing for my sodium carbonate. So it's 94.6 grams sodium carbonate. Alright, and there are 105.99 grams of sodium carbonate in 1 mole. And that gives me 0.893 moles sodium carbonate. Alright, so in this case, right, we now need to compare this mole value to that mole value. And how does those 2 mole values relate to my balanced reaction? So if I come up here, I should notice that calcium nitrate and sodium nitrate is a 1-to-1 ratio. So that makes it really easy. When we have a 1-to-1 ratio in our reaction, it's really easy to pick out my limiting reactant. It's just the one that we have less of. Boom. There's my limiting reactant. Alright, so what that means is I actually don't need this number right here anymore. Don't need this 0.893 moles of sodium carbonate. Alright, so I am just going to erase that to save myself some space on my screen. Alright, so, okay, we're almost there. Now, we know our actual amount. We just have to figure out our theoretical amount, and this is my limiting reactant. So now that I know my limiting reactant, I can predict my theoretical amount. So we're getting there. Let's go here. Let's go orange. Never use orange. All right. So my limiting reactant is 0.503 moles of calcium nitrate. All right. Now I need to look at my mole ratio of calcium nitrate to calcium carbonate, and again it's 1-to-1, which makes this really easy. 1 mole calcium nitrate to 1 mole calcium carbonate. Alright, now in order to figure out my percent yield, I'm going to have to get my value into grams because my actual yield is in grams, right? So one more step. In 1 mole calcium carbonate, there are 100.09 grams calcium carbonate, and that should give me 50.3 grams calcium carbonate. Alright, so again, stoichiometry tells me how much calcium carbonate I ought to get. So this is my theoretical. Alright, so now I know my actual yield, I know my theoretical yield. I've got one more step. It's going to be 31.5 grams over 50.3 grams, right? And then times 100, and that should give me 62.6% yield, right? And we should label what this is, calcium carbonate. done. All right. So this, by the way, will accompany ChemQuest number, you guessed it, 32. See you guys later.